Welcome to this lesson. This lesson is about percent applications. So let's read this question. 30% of the student in Miss Sampay's class like black licorice. How many people are in Miss Sampay's class if 6 students like black licorice? I personally hate black licorice. That's why I did not write my name for this. All right, so there are many ways to do this. We're going to be doing something called flexible thinking, where you can use percent bars, proportion, percent proportion, multiple ways of solving it. So let's think about it. This is a percent bar. What percent is this entire bar? Hopefully you said it is 100%. What do you want to break this down into? I want to break this into 10 equal sections. If I break this into 10, if I break down 100% into 10 sections, what percent represent each section? Hopefully we'll say 10%, 10%, 10%. So the first 10% represents 30%. So 30% of students in Miss Sampay's class like black licorice, which is right here. How many students are in Miss Sampay class if 6 students like black licorice? So 6 students represents 30%. Now we need to find relationship here. There are many ways you can do this. This is one way you could have done it. Well, if you know there's 30%, can you break this down into 10%? How do you break down 10%, 30% to 10%? Divide by 3. So divide this by 3, that would be 2. So I'm going to use a different pen color. 2, 2, 2. That means there are 2 people for every 10%. 2 people for every 10%. So how many total people is that for 100%? That would be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. There are 20 people in our class. One way to do it. Maybe you'll look at that and say, I don't think so. Maybe you find another relationship. Maybe you saw this. How do you turn a 30 to a 6? Divide by 5. Divide by 5. And what is 100 divided in 5 groups? 20 people. What if you don't like any of those ones? Maybe you prefer something called percent proportion. Part over whole equal percent over 100. So we know 30 goes here. And does part of the class like licorice or the whole class? Only part of class, which is 6 people. What's the relationship between 30 to 6? Divide by 5. Divide by 5. 100 divided by 5 is 20. What if you don't like saying divide by 5? Do you remember something called reciprocal? The reciprocal of 5, 1 is 1/5. So times 1/5, a fifth of 30 is 6. So let's practice some more questions. 12% of the students in the school choir like to sing solos. These 12 students make up 24% of the choir. How many students are in the choir? So this whole bar represents 100%. So we know 24%, which is like this part right here, almost 1/4 of it, but not so quite, which is 12 people. So many ways to do this. This is one way you do it. Do you see a relationship between these two numbers? Do you see a relationship, an up and down relationship? Wait. Oh, divide by 2. Divide by 2 or half. Oh, 50 students in a choir. Maybe you don't like that way. I actually had somebody who liked it this way. Can I break 24 down to 4%? Divide by 6. Divide by 6, and that's 2. So there are 2 people for every 4%. How do you build 4% to 100%? Times 25, times 25, and that's where you get 50. What if you don't like that way? Maybe you prefer something called percent proportion. So 24% of the choir like solos, and that's part of the choir. Find the entire whole choir. Oh, relationship is divide by 2. Divide by 2. 50 is the answer. In our last practice, the school principal spent $2,000 to buy some new computer equipment. Of this money, $120 was used to buy new keyboards. What percent of the money was spent on keyboards? So this represents 100%. So all of this was spent on computer, which is $2,000. So $120 goes here, which is part of the money. So let's think. That's going to be part of money, like right here. It's going to be a small number, I predict. So what is the relationship? Can 120 go into 2,000 easily? Not quite. Maybe there's an up and down relationship. How do you turn 2,000 to 100? Let's see. Let's divide this and figure out. Can 100 go into 2? 0 times. Can 100 goes in 20? 0 times. Can 100 goes in 200? 2 times. Break this down. 100 goes in 0? 0 times. So the relationship is divide by 20. Divide by 20. So 120 divided by 20 is 6%. That is the answer. 6%. Maybe you don't like it that way. Here's a shortcut. Here's another way you could have done it. Could we have simplified this? Divide by 100. 2,000 divided by 100 is 20. 100 divided by 100 is 1. How do you turn a 20? What's the relationship between 20 to 120 times 6? 1 times 6 is 6%. What if you don't like the percent bar? You prefer something called percent proportion. Part over whole equal percent of 100. So $2,000, the whole amount he spent on a computer. Part of it was spent on keyboards. So do you see an up and down relationship or a side-to-side relationship? I see a side-to-side relationship. So I could divide by 20, divide by 20, or maybe you want to say times 1/20th, and that's 6%. Maybe you prefer to simplify this by dividing by 10. How do you turn a 200 to 100? Divide by 2. 12 divided by 2 is 6%. So what you're going to do for the rest of the class is you're going to be working on 5 different problems using flexible thinking, using percent proportion, or percent bar. Good luck.